Let's start by deciding which way is going to be positive for this question. Well, the big fish is swimming to the right. Let's choose that to be positive. So, big fish here is how big is he? 5 kilograms, and he's going along at 1 metre per second. And there is another fish, a smaller fish, which is 1 kilogram, and it's at rest. It's not swimming along at all, it's just sitting there having a nice day, not for much longer. Afterwards, the big fish eats the small fish. So we don't actually have this situation anymore. The two have merged together into one big fish, small fish, fish lunch, big massive fish. So fat fish. So let's draw what that looks like. Here's afterwards. Afterwards we have a mass of 6. Okay, so we're going to ignore water resistance and we're going to say, what is the velocity afterwards? Now I'm just assuming, after it's eaten its lunch, I'm assuming it's going right. This is my positive direction. If this comes out negative, I'll know that it was actually going the other direction, but I doubt that's going to happen. So what's our momentum before? Our momentum before, 5 times 1 plus 1 times 0. Better have a little think before I did that a bit quickly. Is this positive? Yes. Same direction? Yes. Yes. Positive? Yes. Positive. Good. Momentum afterwards is 6v. Conservation of momentum tells us that these are the same. So 5 equals 6v. So v equals, just calculated that because my brain isn't working, 1.2 metres per second. So that is the velocity of the larger fish immediately after his lunch. Now, this situation, the little fish, he's not just sitting there, he's actually swimming towards the big fish. Again, I'm going to take this to be positive to the right, why not? So, big fish, 5, I think he was kilograms, small fish, 1 kilogram. Big fish swimming along at, how fast was he swimming? Can't remember. 1 metre per second. He's swimming at 1 metre per second. Small fish now swimming in the opposite direction at 4 metres per second. Afterwards, big fish, little fish, fish lunch, 6 kilograms, and we want to know how fast the big fish will be going. Do you think faster or slower than before? We got 1.2 before. Let's try. So momentum before, 5 times 1, is that positive? Positive, yes. Plus 1 times 4, is the 4 positive? No, this is positive direction, the 4 is going in the other direction. So that's actually a minus 4, that's momentum before. Momentum afterwards is 6v. We know from conservation of momentum that the momentum before equals the momentum afterwards. So 5 minus 4 equals 6v. So 1 equals 6v. So v equals 0.167 metres per second. Maybe I should do 2 significant figures, 0.17 metres per second. So it's slowed down, of course it has, because the momentum of the fish, it now has momentum, it didn't have any momentum before. The momentum of the small fish has been transferred into the big fish when they collided and the big fish ate the small fish, and that has slowed the big fish down after he's had his lunch. Small fish is going even faster now. Let's take this to be positive still. So we've got our big fish going at 1 metre per second, and our small fish is now going twice as fast, 8 metres per second. I don't know why he's swimming towards this big fish. It's clearly going to eat him, but anyway, that's what he's doing. So afterwards, oh no, we haven't got big fish afterwards. We've got massive big fish, lunch fish, heavy fish. Fish in fish. There we go. Same as before. Let's see what happens this time. So our momentum before, 5 times 1 plus 1 times 8. So you should never do what I just did there. I deliberately did that to make a point. Always, is this positive or negative? Is this positive or negative? Here's my positive. 1 is positive, 8 is not. 8 is negative. So you have to be really careful to get that right. Afterwards, 6v. Okay, so there's my v, positive, yes, good, 6v. Conservation of momentum tells us that the momentum before will equal the momentum afterwards. So 5 minus 8 equals 6v. Minus 3 equals 6v. We've got a speed of minus 0.5 metres per second. Now, that minus there is relative to this direction as positive. So all that's telling me is that it's going in the opposite direction to the one I said was positive. So when I wrote this arrow like this going right, I didn't actually know that the big post-lunch fish would be going in this direction. I just guessed, and the V's come out negative, so that means this was wrong. So actually the velocity of the big fish afterwards is 0.5 meters per second, but in the opposite direction to the direction the big fish's previous, I don't know how you'd phrase that, but anyway, it's going in the opposite direction to the where it was going before, and that's because this little fish had so much momentum, it was zooming along at 8 meters per second, shot into the mouth, and even though the big fish is even bigger and is going this way, those combined and the momentum is the same afterwards, and that causes the big fish with the little fish inside to move to the left. So we've seen a situation where the big fish ends up going to the right, goes to the right a bit slower, goes to the left. How fast would the small fish need to be going in order to bring the large fish to rest after its lunch? So let's choose a direction for positive. I'm going to choose right, why not? Big fish, 5, 1. Small fish, 1. Don't know. Afterwards, big fish with small fish inside, 0. That's what we want, bringing it to rest. So momentum before, 5 times 1, check, check, yes, positive, good. Plus 1 times V, check, negative. V is negative because it's going in the opposite direction, so that's actually minus V there. Afterwards, 6 times 0 because it's come to rest. Conservation of momentum, 5 minus V equals 0, so V equals 5 meters per second. So if the fish was going at 5 meters per second, then it would shoot into the big fish's mouth, and then the big fish would come to a halt and just be sat there in the middle of the sea. Now this one looks different, but it's actually sort of the opposite. Instead of having two fish coming together into being one fish, we've got a bullet inside a gun, which we could sort of think of as one particle, and then after the bullet is fired out of the gun, you've got a bullet going that way and a gun going that way by recoil. So actually it's sort of the opposite of the fish eating lunch example. Let's choose a direction to be positive. I will choose that one again, and let's put our masses inside. So our gun has mass 2.5 kilogram, bullet has mass 0.025 kilogram. So when they are all together in one thing, the gun bullet is 2.525 kilograms. Okay, the bullet leaves the gun with a velocity of 250 meters per second, and the time taken to fire is 0.001 seconds. We want to find the velocity of the gun, that's the V, and various other things. So let's just start with the velocity of gun. Initially the system is at rest, so that's a velocity of 0. So what have we got? Momentum before is 0. The momentum afterwards is 2.5 times V. Is V positive or negative? Just check. Oh, didn't mean to do that. Oh dear, I ended up with something scary. Okay, here's positive, here's V, negative. Opposite, so negative. So there's minus V plus 0.025 times 250 is the momentum afterwards. Using conservation of momentum, we get 0 equals minus 2.5V plus 250, oh, helps if the calculator's on, 250 times 0.025, which is 6.25, and that gives us a velocity of 6.25 divided by 2.5, which is 2.5 meters per second. 2.5 meters per second. Let's try the next bit. Give myself a bit of room. The force on the bullet. Just put that there in case I need it again. Put it up there. So the force on the bullet. So I am the bullet. Here I am. And I feel a force in that direction. So I'm going to take that direction to be positive. And since I am the bullet, I have mass 0.025 kilogram. Now the force multiplied by the time is equal to the impulse that I feel. So what is my impulse? Let me just go back to my other picture and have a look at my impulse as the gun. So when I'm the bullet. So the bullet, initially it had no momentum, and then afterwards its momentum was 250 times 0.025. So I'm going to use that to work out the impulse, and then I'm going to use that to work out the force. So impulse is mv minus mu. I am the bullet, so I am 0.025. My final velocity is 250 meters per second. My original mass was still 0.025 because I'm the bullet, but I wasn't moving. So this is, didn't I just do this calculation? Yeah, 6.25. So the impulse is 6.25 newton seconds. Now 6.25 newton seconds is the force times the time, and I know the amount of time was 0.001 seconds. So 0.001 seconds multiplied by the magnitude of the force is equal to 6.25, giving me a force of 6.25 divided by 0.001, which is 6250 newtons. So I've actually worked out both parts of that question. I've got the force on the bullet, 6250 newtons, and I actually found the impulse on the bullet first in order to find the force. So I've got that as well, 6.25 newtons.